How many tangents can I draw at a point on a circle? Let us do a small activity to find this. Take a point P inside the circle. Why is it not possible to draw a tangent to circle through a point inside the circle? We know that a tangent should have only one point of contact with the circle. If we draw lines through this point, it will intersect the circle in 2 points. So, it is not possible to draw any tangent to a circle through a point inside it. If P is a point on the circle, then a tangent can be drawn at that point on the circle. What do you conclude from this? No tangent can be drawn at a point lying inside the circle, and there is one and only one tangent to a circle passing through a point lying on the circle. Can you draw tangents to circle through a point lying outside the circle? Yes, we can draw tangent to a circle from a point outside the circle. If T1 and T2 are the point of contacts of the tangents, then PT1 and PT2 are the lengths of tangents from P to the circle. So, the length of tangent is the length of line segment of the tangent from the external point P and the point of contact with the circle. What common property do you observe if you measure the lengths of tangents PT1 and PT2? We find that the lengths of tangents drawn from external point to a circle are equal. How do you prove this using logical arguments? To prove this, let O be the center of circle and P be a point outside it. Let PQ and PR be the tangents drawn from point P. In right-angled triangle OQP and ORP, OQ is equal to OR, radius of the same circle. OP is equal to OP, common. PQ is equal to PR, CP/CT. So the lengths of tangents drawn from a point are equal. Is there another method of proving this? Yes, it can be proved using Pythagoras theorem. By applying Pythagoras theorem to triangle OPQ, we get OP square is equal to PQ square plus OQ square. PQ square is equal to OP square minus OQ square. But OQ is equal to OR. So, PQ square is equal to OP square minus OR square. But PR square is equal to OP square minus OR square. Therefore, PQ square is equal to PR square, which implies PQ is equal to PR. Now, let us solve problems related to properties of tangents. From a point Q, the length of tangent to a circle is 24 centimeters and the distance of Q from the center is 25 centimeters. How do you find the radius of the circle? A tangent to a circle is perpendicular to the radius through the point of contact. So, OP is perpendicular to PQ. The length of radius can be found using Pythagoras theorem. According to Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. OP square plus PQ square is equal to OQ square. Therefore, OP square is equal to OQ square minus PQ square. Substituting the values and simplifying, we get OP is equal to 7 centimeters. If tangents PA and PB from a point P to a circle with the center O are inclined to each other at angle of 80 degrees, then how do you find the measure of angle POA? A tangent to a circle is perpendicular to the radius through the point of contact OA is perpendicular to PA and OB is perpendicular to PB. Therefore, angle OBP is equal to angle OAP is equal to 90 degrees. We know that sum of all internal angles of quadrilateral is 360 degrees. Therefore, sum of all the angles OAP, APB, PBO and BOA is equal to 360 degrees. Substituting the angles and adding them up, we get angle BOA is equal to 100 degrees. OA is equal to OB, radii of same circle. OP is equal to OP, common to both triangles. PA is equal to PB. Length of tangents from a point are equal. Triangle OPB is congruent to triangle OPA by SSS congruency criterion. Therefore, angle POA is equal to angle POB. Angle POA is equal to half the angle BOA, that is equal to 100 by 2, which is 50. So, the measure of angle POA is equal to 50 degrees. If two concentric circles are of radii 5 cm and 3 cm, then can you find the length of the chord of the larger circle which touches the smaller circle? To find this, let us prove a relation between the chord and the concentric circles. Let C1 and C2 be two concentric circles with center O, and let chord AB of the larger circle touch the smaller circle at point P. Here, AB is a tangent to circle C2 at point P. Tangent to a circle is perpendicular to the radius through the point of contact. Therefore, OP is perpendicular to AB. AB is also a chord of the circle, but perpendicular from the center of the circle bisects the chord. Therefore, AP is equal to BP. In two concentric circles, if the chord of the larger circle touches the smaller circle, then the chord is bisected at the point of contact. The length of chord AB can be found by applying Pythagoras' theorem to triangle OAP. Substituting the known values and simplifying, we get value of AP is equal to 4 centimeters. So, the length of chord is equal to 2AP, that is 8 centimeters. Tangents are drawn at the ends of a diameter of a circle. How do you prove that tangents drawn at the ends of a diameter of a circle are parallel to each other? To prove this, let us draw two tangents. PQ is equal to RS at points A and B. We know that radius drawn to two tangents will be perpendicular to the tangent. So, OA is perpendicular to RS and OB is perpendicular to PQ. Therefore, angles OAR, OAS, OBP, OBQ are all equal to 90 degrees. From this, we observe that angle OAR is equal to angle OBQ and angle OAS is equal to angle OBP. But these are alternate interior angles. Two lines are parallel if they obey the property of parallel line. Therefore, PQ is parallel to RS. So, tangents drawn at the ends of a diameter of a circle are parallel to each other. If all the sides of a parallelogram touch a circle, then how do you prove that the parallelogram is a rhombus? To prove this, let us take ABCD as a parallelogram and let its sides touch the circle at points P, Q, R, and S. The opposite sides of a parallelogram are equal, so AB is equal to CD and AD is equal to BC, that is equation 1. Here, we observe that AP and AS are tangents from the point A. BP and BQ are tangents from point B. CR and CQ are tangents from point C. And DS and DR are tangents from point D. Lengths of tangents drawn from external point to a circle are equal in length. Therefore, AP is equal to AS, BP is equal to BQ, CR is equal to CQ, and DR is equal to DS. Adding up all these equations and simplifying, we get AB is equal to BC. Comparing equations 1 and 2, we get AB is equal to BC, that's equal to CD, and that's equal to DA. All sides of a rhombus are equal, so ABCD is a rhombus. Therefore, a parallelogram inscribing a circle is a rhombus.